I want you to think about a couple of routers that are talking to each other and exchanging EIGRP information. Now, when these routers who are talking to each other are reloaded, what would normally happen? Well, when you consider that these routers have a peer relationship with each other, if this router were to reload, then that peering between these two devices would go away. Same would happen between the two routers on the left-hand side. So if we reload, then the peers are removed. So if the router in the center, we'll call that router A. If router A goes down, then router B and router C are going to remove the peers. When router A comes back up, then the peers would reestablish. Now, what happens when a peer is removed? Well, the routing table loses all of the routes that were learned by that peer. So, now that the peers have been rebuilt after the router A here in this example comes back up, now that the routers have rebuilt that peering relationship, they relearn routes, and then they reinsert those routes into the routing table, and they can then again forward traffic. Now that is a bit of time that happens there, which causes some convergence issues. It takes a while to converge. How can we speed that up? Well, the answer is Graceful Restart and Non-Stop Forwarding, or NSF. So essentially, what we have is two different protocols that Graceful Restart utilizes. It'll either utilize SSO, which is Stateful Switchover, or ISSU, which is In-Service Software Upgrade. Now, these are two protocols that would run on devices that have dual processors. So this is for dual processor systems. The dual processors that support SSO or ISSU can forward while they're restarting the control plane on the second processor. So that's what happens here. So when A goes down for its reload, router C and router B both know through messages that were exchanged ahead of time that they can give a grace period while router A is reloading. So Graceful Restart reduces the EIGRP convergence times. So whenever that networking device restarts, the peers detect that that device is down, and we remove those routes. But with SSO and ISSU on a dual processor system, we can reboot the control plane on one processor and continue forwarding with the other. So ahead of time, the peer devices have to be informed that a router is capable of stateful switchover. Now, when peer devices are informed, and they have to understand this as well, when they're informed that stateful switchover is a capability of a router, it then allows a grace period. So Graceful Restart suppresses the routing changes on the peers. In other words, the peer devices don't need to remove the routes from the routing table and wait to reestablish the peer and then reinsert the routes. So any known routes that we have before a router goes down will remain in the routing table and will continue to forward. So what does this do for me? Well, Graceful Restart reduces instability in the network as well as downtime, right? So it speeds up convergence because we don't really have to reconverge, and that's a good thing.